this lesson will be on stationary points. Now, a stationary point is a point on the graph where the gradient of the tangent is equal to 0. So I've got a visual representation of this here. If we called the x-coordinate of that A point, let's call it -2. If we called that x-coordinate B 1, and if we called that x-coordinate C 5, we could say that, okay, when x equals -2, the gradient of the tangent at this curve is equal to 0. Likewise, at these 2 points, the gradient of the tangent at those 3 points is equal to 0. In other words, the tangent is horizontal to the x-axis. It has a gradient of 0. And the way we go about solving the gradient of the tangent is by finding the derivative. So we're solving for stationary points the derivative dy dx equal to 0. Let's jump straight into a question. Find the stationary points of the following functions. We might just have a look at part A and part C, as the process for each of these is the same. So we've got y equals 9 plus 12x minus 2x squared. Just to help you visually, I've got a graph of this curve here. So over here we've got 9 plus 12x minus 2x squared. So we're trying to find the point on this graph where the gradient is equal to 0. And you might be looking at this graph and thinking straight away, well, I think it's going to be up here at the turning point, because at that point there we're going to have a horizontal line for the gradient, which will be of a value of 0. But let's go ahead and solve it to see if we're right. So dy dx, we need dy dx equal to 0. So our derivative of this y here will be dy dx equals 12 minus 4x. We solve 12 minus 4x equal to 0. We'll get 4x equals 12, so x equals 3. So in other words, when x equals 3, so over here on our graph, the gradient at that point, so up here, is 0, which is what we were expecting. So the tangent there would be a horizontal line with a gradient of 0. But we were asked to find the coordinates, or the points, so we can sub when x equals 3 into our original rule. So we'll get y equals 9 plus 12 times 3 plus 2. That's a minus 2 times 3 squared. We'll get 9 plus 36 minus 18, which equals 27. So we can say, therefore, stationary point at 3:27. And just going back to our graph again, that would be this point up there, 3:27. Alrighty, let's have a look at part C. As I said, all these questions are the same process, so we'll just have a look at A and C, and you can have a go at B in your own time. So part C, we've got the graph y equals 4 plus 3x minus x cubed. Y equals 4 plus 3x minus x cubed. I don't have a graph for this one to help you visualize it, but hopefully you've got the idea now of stationary points. So we want to solve the derivative dy dx equal to 0. So our derivative will be 3 minus 3x squared equals 0. Now there's a couple of ways we could solve for x here. We could factorize out of 3, but there's not really any need. We can just straight away solve 3x squared equals 3. So x squared equals 1, and we'll get x equals plus or minus 1. If I come over here, because we need to find our y coordinate, when x equals 1, we sub that back into our original, we'll get y equals 4 plus 3 times 1 minus 1 cubed, which will be 4 plus 3 minus 1, which equals 6. So we've got a coordinate at 1, 6. And when x equals -1, we'll get y equals 4 plus 3 times -1 minus -1 cubed. So we'll get that equal to 4 minus 3. That will become plus 1, which will give us coordinate of 2. So the other coordinate is -1, 2. And let's just summarize by saying, therefore, stationary points at 1, 6 and -1, 2. So in other words, at those 2 points, the gradient of the tangent is equal to 0. Alrighty, let's have a look at one more question. This question is a little bit different to the previous ones, but it involves the same concept of stationary points. So we've got a curve with that equation with some unknown values a, b, and c passing through 0, 5 and has a stationary point at 2, 7. We need to find the values of a, b, and c. Now straight away we'll be able to find the value of c by just substituting in the coordinates 0, 5 here. So we've got y equals x cubed plus ax squared plus bx plus c. We know that at 0.05, we substitute that into our equation there, we'll get 5 is equal to 0 plus 0 plus 0 plus c. So we know c is equal to 5 straight up. Alrighty, if we keep going though, we'll be able to find a and b using this information about the stationary points. So our new rule will become x cubed plus ax squared plus bx plus 5, since we know c is 5. If we know that we have a stationary point at 2, 7, we know that at that point there, 2, 7, the derivative will be equal to 0. So dy dx equals 3x squared plus 2ax plus b. And we know at the point 2, 7, we know it's a stationary point, so we know that dy dx equals 0. So if we substitute x equals 2 into our derivative here, we'll get 0 for the derivative is equal to 3 times 2 squared plus 2a times 2 plus b. So we're left with 0 equals, that'll give us 12 plus 4a plus b. Alrighty, I'm going to label that equation number 1 because in a moment we're going to come up with another equation and we'll have to solve them simultaneously to find a and b. The other bit of information that we know is, we know that given it's a stationary point at 2, 7, we know that 2, 7, those coordinates, it actually lies on the curve itself. It can't be a stationary point on the curve if the coordinates don't actually lie on the curve itself. So we can substitute 2, 7 into our original. So we'll get at 2, 7. If I just sub that into our equation here, we'll get 7 equals 2 cubed plus a times 2 squared plus b times 2 plus 5. So we'll get 7 equals 8 plus 4a plus 2b plus 5. Let's make that equal to 0. So we'll get 0 is equal to 4a plus 2b plus 6. That will give us. Alrighty, let's call that equation number 2. So we've got this first equation here, we've got this second equation here. We need to use simultaneous equations to find A and B. So why don't we go ahead and subtract 2 from 1. If we subtract this equation from this one, we'll get 0 equals 12 minus 6 will give us 6. 4a minus 4a, they'll cancel. That's why this method is helpful for us for solving simultaneous equations, because we'll get rid of the 4a's there, and then we'll end up with b minus 2b will give us minus b. So we know that b is equal to 6, and that's our b value. So we've got our b value, we've also got our c value previously in the question. To get our a value, so b equals 6 into number 1 or number 2, doesn't matter. Let's go with number 1. So we'll get 0 equals 12 plus 4a plus 6. So we're left with 4a equals minus 18. We're left with a equal to minus 9 over 2. So hopefully that's been a helpful introduction to stationary points.